Imagine relying on a foreign country's satellite network to, guide your military's logistics or your civilian aviation or even your missiles.
Right.
And then right in the middle of a geopolitical crisis, that foreign country just flips a switch and turns your GPS access off.
Yeah, you're just flying blind.
Exactly. Suddenly, you are completely flying blind. And for decades, that scenario has been like the ultimate strategic nightmare for emerging global powers.
Oh, absolutely.
And today, we are looking at exactly how billions of dollars are being spent to ensure that never, ever happens to India.
It's a terrifying scenario, honestly, and it gets right to the heart of what we are analyzing today, because when we look at the stack of government affairs material, the policy documents, the technology roadmaps we've got in front of us, the narrative around India's space program has, well, it's fundamentally fractured from the past.
Right. It's totally different now.
Yeah, it's no longer this public relations exercise about planting a flag on the moon. I mean, it is a massive structural pivot toward strategic autonomy and, crucially, dual-use technological power.
Welcome to this deep dive. Today, we are putting together a strategic policy analysis, and we're treating this like a current affairs war room discussion.
For sure.
If you've been tracking global power dynamics, you know that space is the new high ground. So our mission today, for you listening, is to decode India's space power revolution. We're going to look at the hardware they are building, the legal frameworks they're desperately trying to patch, and the stark vulnerabilities that are actually holding them back.
And to really understand the velocity of this shift, you have to look at the immediate baseline. I mean, 2023 was the absolute inflection point.
Right, Chandrayaan-3.
Exactly. You had Chandrayaan-3 successfully landing on the lunar South Pole. And, that is not just some geographical novelty. The South Pole is heavily cratered, it's permanently shattered in areas, and incredibly difficult to navigate.
It's technically brutal.
Yeah, brutal. And following that up with the Aditya L1 Solar Observatory, I mean, that proved that the Indian Space Research Organization, or ISRO, has mastered incredibly complex orbital mechanics. So they moved from being just a reliable launch service to a lead architect in planetary exploration.
But, and this is the kicker, planetary exploration doesn't automatically equal economic dominance.
No, not at all.
When you map out the timeline the government is operating on, the sheer aggression of the scheduling is what really stands out to me. So we go from those 2023 science missions right into 2024, where the government approved a 10 billion rupee fund.
Right, and that's specifically to inject venture capital into space startups.
Exactly. It's a huge shift. We are moving from just building the vehicles to essentially building the entire highway system and the gas stations.
That's a great way to put it. And that capital injection is meant to accelerate the next tier of milestones. Because if you want to remember the hard data points here, 2025 is the target for the Gaganyaan program, which is the first indigenous human spaceflight.
Okay, 2025.
Yeah. Then, by 2031, policy documents are targeting a massive slice of the projected $14 billion global market for small satellites. And then you have the true anchor of this entire strategy, which is 2035.
Right.
2035 is the target year for a fully operational national Indian space station.
Wait, 2035 for a fully operational space station? I mean, that is only a decade away.
Yeah, it's right on the corner.
Given they haven't even put a human in orbit yet with Gaganyaan, isn't that timeline like completely unrealistic?
Right.
We're talking about leaping from basic rocketry to sustained orbital habitation.
It is an incredibly steep curve, I mean, no doubt, which is exactly why the focus has shifted away from isolated launches toward building infrastructure. You can't just launch an entire space station on one rocket.
Oh, of course not.
You have to launch it in modules over several years and physically piece them together in the vacuum of space. And that brings us to a crucial data point from the sources. The SpaceX mission.
Ah, yeah, SpaceX, space docking experiment. The material we're looking at highlights this as a total linchpin technology. But explain the mechanics of this, because docking two things in space isn't just like parallel parking a car.
Not at all. I mean, imagine two objects designated as the chaser and the target, right? And they are moving in low Earth orbit at roughly 17,500 miles per hour.
Oh, wow.
Yeah. At those speeds, even a millimeter of misalignment results in a catastrophic collision. It just creates a massive cloud of shrapnel.
Right.
So SpaceX is designed to test autonomous docking. There is no astronaut with a joystick making micro adjustments here.
Wait, really? It's entirely automated?
Entirely. The satellites have to use onboard radar, LiDAR and optical sensors to find each other in the dark, calculate their relative velocity, fire microthrusters, and then physically lock together seamlessly.
So it's essentially threading a needle while riding a bullet, entirely controlled by onboard algorithms.
Exactly. And once you master autonomous docking, you haven't just learned how to build a space station. You have also mastered on-orbit servicing.
Oh, I see where this is going.
Yeah, you can send a chaser satellite to refuel a dying communications satellite. Or if we look at the dual-use military applications, you can send a satellite to intercept, inspect, or even disable a foreign asset. That is exactly why SpaceX is a foundational strategic capability.
And what's fascinating is that ISRO isn't building all of this in a vacuum anymore. The data shows over 30 Indian companies are currently collaborating to build Earth observation constellations.
Right.
And there are over 40 distinct startups actively building launch vehicles, sensors, and satellite buses.
Which forces us to look at how this technology actually integrates into the domestic economy. I mean, you cannot understand this space revolution without looking at broader governance frameworks. Things like Atmanirbhar Bharat, which translates to self-reliance, or the push for a digital India.
Yep, everything is interlinked.
Exactly. The government isn't just funding these 40 startups for national prestige. They are funding them to solve massive socio-economic bottlenecks on the ground.
Let's trace that cause and effect for the listener. Like, how does an Earth observation constellation actually change the daily reality of governance?
Well, look at agriculture. The sources detail ISRO's Bhuvan geoportal.
Okay, the Bhuvan geoportal.
Yeah, which is essentially this indigenous, hyper-detailed geospatial platform. And the government is currently using satellite data to directly support the PM Kisan scheme, which is a massive farmer income support initiative.
Right, but I have to ask, how does a satellite in orbit help a bureaucrat disperse funds to a farmer? What is the actual mechanism there?
It all comes down to multispectral imaging.
Okay.
So a satellite doesn't just take a regular photograph like your phone. It captures light in the near-infrared spectrum. Healthy crops reflect near-infrared light very strongly, while stressed or, drought-stricken crops absorb it.
Oh, interesting.
Right. So by running this satellite data through algorithms, the government can instantly assess the health of millions of acres of farmland without sending a single inspector into the field. They can predict yield shortages, they can verify crop damage for insurance claims, and they can disperse relief funds directly to farmers' bank accounts with zero middlemen. It is a massive leap in the ease of governance.
But getting those multispectral cameras into orbit requires consistent, cheap access to space.
Exactly.
And this is where the hardware evolution comes in, specifically the SSLV, right? The Small Satellite Launch Vehicle.
Yes, the SSLV.
Because up until now, India's workhorse has been the PSLV, which is a massive rocket. Why the sudden pivot to the SSLV?
Well, it's because the global market has fundamentally changed. We aren't just launching school bus-sized satellites anymore. Startups and university labs, they are building nanosatellites the size of a shoebox.
Right.
And if you want to launch a shoebox, you really don't want to pay for a school bus-sized rocket.
Yeah.
And you definitely don't want to wait 6 months for it to be built. The SSLV is designed for rapid deployment.
From what I understand about the manufacturing process, it's almost like the difference between building a custom mansion and assembling flat-pack furniture.
That is a highly accurate comparison, actually. Traditional rockets are often integrated vertically, over weeks or months on these massive launch pads. But the SSLV is designed for horizontal integration.
Okay.
It can be assembled quickly, transported easily, and launched with minimal infrastructure and a fraction of the personnel.
Wow, so it's all about speed.
Exactly. This rapid turnaround is exactly how India plans to capture that $14 billion small satellite market by 2031. It lowers the barrier to entry so those 40 domestic startups can actually afford to get their hardware into orbit.
And this brings us back to that nightmare scenario we started with, the whole idea of relying on foreign infrastructure. If you were building an entirely digitized economy, from agricultural disbursement to digital payments, you need an atomic clock and precise location data.
Absolutely.
And that is why the upgrade to NAVIC is so heavily emphasized in these policy documents.
Yes, NAVIC. This is India's indigenous regional navigation satellite system. Now, for decades, the world has relied on the American GPS system or the Russian GLONASS. But GPS is a military system controlled by the U.S. Department of Defense. If you are relying solely on GPS, you are essentially leasing your data sovereignty.
So NAVIC CREASY is basically the insurance policy.
It is way more than insurance. It is a critical defensive perimeter. NAVIC operates on dual frequency bands, the L5 and S bands, which actually makes it highly resistant to signal spoofing and atmospheric interference.
Okay, that's crucial.
Right. So in a geopolitical conflict, if an adversary tries to jam global positioning signals, or if the operator of GPS degrades the signal over your airspace, your military can instantly switch to NAVIC. Your missiles still find their targets, your naval fleets can still navigate, and your telecom grids don't collapse.
So it's a double-edged sword, really. I mean, democratizing the space sector with startups opens the door for massive innovation, but it also creates a pipeline for sovereign infrastructure. The startups aren't just building toys. They are building the Earth observation and navigation nodes that the state will rely on.
Which is precisely the intent codified in the 2023 space policy. The policy transitions ISRO away from day-to-day commercial launches and repositions it as an advanced research and development hub,
Right.
all while explicitly directing the private sector to step up and build end-to-end space capabilities.
But, I have to challenge this whole startup utopia narrative a bit.
Sure.
We are talking about international partnerships,
Yeah.
like the NASA-ESA collaboration on the NISAR satellite and India signing the Artemis Accords for lunar exploration. It sounds incredibly collaborative.
On the surface, yes.
But isn't there a risk of just creating a massive bubble? Like, if we are throwing 10 billion rupees at 40 startups without a heavy-handed strategic direction, aren't we just subsidizing companies that might get bought out by foreign prime contractors the minute they develop something useful?
That is a very real vulnerability, and it's exactly why the integration of defense and space is becoming much more overt. The militarization of space isn't a future concept, it is happening right now. You look across the border at China's rapid deployment of anti-satellite weapons and these dedicated military reconnaissance constellations, and that collaborative, peaceful veneer of space exploration starts to fade pretty fast.
The sources specifically mention the GSAT-7 series of satellites to
Yeah.
counter this, right?
Yes. The GSAT-7 series represents a dedicated military communications backbone. Before this, the Indian Armed Forces actually had to share bandwidth with civilian telecom satellites.
Oh, wow. I didn't realize that.
Yeah, it wasn't ideal. Having a dedicated military satellite provides secure, encrypted, high-bandwidth communication in real time across the entire Indian Ocean region. I mean, it connects warships, submarines, and airborne early warning aircraft into a single, cohesive network.
Okay, so we had the ambition, we have the strategic imperative, and we have some very impressive hardware in orbit. But let's pause, do a reality check.
Let's do it.
Because reading through the global economic data, there is a glaring, almost absurd contradiction here. If India is landing on the lunar South Pole and launching autonomous docking experiments, why does it only hold a 2 to 3% share of the global space economy?
That is the defining paradox of India's space program right now. That 2 to 3% figure is a harsh reality check.
It's tiny.
It is. It reveals that capability demonstration has not yet translated into commercial or technological dominance. And when you look under the hood, the structural bottlenecks are severe.
Let's pull apart those bottlenecks. Where are the actual gaps? Because it feels like they have this high-performance sports car, but they are terrified of running out of gas, and they don't even know how to manufacture their own tires.
The primary gap is deep tech dependency. We celebrate the rockets, but what actually goes inside the rockets? India still relies heavily on foreign imports for advanced sensors, high-grade aerospace materials, and crucially, semiconductors.
Now, space-grade chips are entirely different from the chips in your smartphone, right?
Fundamentally different. In orbit, a satellite is constantly bombarded by cosmic radiation. A standard microchip will suffer what's called a single event upset. Essentially, a radiation particle flips the 0 to a 1 in the computer's memory, and the entire system crashes.
Yikes.
Yeah, you need radiation-hardened semiconductors. And currently, India does not have the robust indigenous foundries required to manufacture these at scale. They have to import them, which leaves the entire supply chain vulnerable to foreign export controls or, geopolitical sanctions.
And what about the Gaganyaan mission? You mentioned 2025 for human spaceflight, but the data shows significant delays.
Because keeping a human alive in the vacuum of space is exponentially harder than keeping a robotic probe functioning.
I can imagine.
The bottleneck there is the Environmental Control and Life Support System, the ECLSS. It is a highly complex closed-loop system that has to scrub carbon dioxide, regulate thermal extremes, recycle moisture, and maintain atmospheric pressure. Historically, only the US, Russia, and China have truly mastered this. India is currently facing delays as it navigates the intense engineering required to develop or acquire these life support systems.
So the hardware and supply chain gaps are massive.
Yeah.
But what about the software of the state, like the regulations? You mentioned the 2023 space policy opening the doors for private capital. But, I mean, money hates uncertainty.
Oh, completely. And right now, the Indian space sector is operating with a significant amount of legal uncertainty. The 2023 policy was a necessary first step, but it is effectively just a statement of intent. It lacks robust, codified legal frameworks for crucial issues like intellectual property rights, dispute resolution, and most terrifyingly, liability.
Let's paint a picture of that liability gap for the listener.
Yeah.
Imagine one of these new Indian startups uses the SSLV to launch a 50-kilogram experimental satellite.
Yeah.
Something goes wrong with the thrusters, it drifts out of its orbital slot, and it slams into a billion-euro French military communication satellite at 17,000 miles per hour. Under the current domestic legal framework, who writes the check?
That is exactly the nightmare scenario keeping investors up at night. The international framework, primarily the 1967 Outer Space Treaty, states that the launching state is ultimately liable.
Okay, the state.
But domestically, India has not clearly legislated how that financial liability is transferred or capped for a private startup. If a venture capitalist knows their tiny startup could be on the hook for a billion-euro international incident, they aren't going to invest.
No way.
Without a codified Space Act that outlines insurance mandates and liability caps, scaling that 2 to 3% market share is going to be incredibly difficult.
And, well, if the capital doesn't flow, the talent doesn't stay.
Precisely. The brain drain is another critical vulnerability. ISRO has brilliant engineers, but they operate on government salaries. When global space giants like SpaceX, Blue Origin, or heavily funded European startups come hauling with massive compensation packages and state-of-the-art facilities, retaining that top-tier talent becomes a severe challenge.
So when we look at the board, we see the 10 billion rupee fund acting as a catalyst. We see the push to secure data sovereignty with NAVIX. We see the drive for military high ground with GSAT-7. But it is all fighting against this heavy undertow of tech dependency and legal voids. How does a state actually engineer its way out of this?
It requires a multi-pronged evolution. First, you have to close these institutional gaps. The legislature needs to pass a comprehensive Space Act that clearly defines intellectual property ownership for space tech and establishes clear liability caps for startups. You just have to give private capital the legal safety net it needs to operate.
And on the hardware side, I mean, you can't just legislate a semiconductor into existence.
No, you can't, but you can direct public-private partnerships to build the foundries. The government needs to aggressively scale up subsidies for indigenous manufacturing of radiation-hardened electronics and advanced propulsion systems.
Right.
And strategically, India needs to leverage its international agreements. Signing the Artemis Accords shouldn't just be a diplomatic handshake. It needs to be leveraged into active technology transfer and joint research in deep space exploration.
Okay, we've covered a massive amount of ground here. Since our mission today is to turn this analysis into an exam-focused framework, can you synthesize all these moving parts into a highly structured, 250-word answer mental map for the listener?
Absolutely. This is your high-scoring conversion framework. Start with your context. You frame India's transition from civilian exploration to strategic autonomy, and you cite Chandrayaan-3 and the SpaceX autonomous docking mission as your proof points.
Okay, context first. What's next?
Next are your dimensions. You analyze the shift through 3 lenses. First, civilian, citing the Bhuvan geoportal and the PM Kisan scheme. Second, commercial, highlighting the SSLV and the 40-plus domestic startups. And third, strategic, underlining the GSAT-7 defense satellite and NEVIS-C for data sovereignty.
Perfect. So context, dimensions, and then the reality check.
Right, the challenges. You must highlight the paradox of holding only a 2 to 3% global market share. Mention the deep tech dependence on foreign semiconductors and ECLSS systems, and point out the intellectual property and liability gaps in the 2023 space policy.
And then we close it out with the solutions.
The way forward. Use administrative vocabulary here. Recommend institutional strengthening via a robust Space Act, public-private partnerships to scale that 10 billion rupee startup fund, technology adoption for indigenous foundries, and international cooperation leveraging the Artemis Accords.
Right.
Finally, your conclusion. Simply state that space is the ultimate high ground, and capability here secures India's economic and national security architecture.
That is incredibly clear. So when you step back and look at this entire deep dive, the scale of what is happening is staggering. We started by talking about Chandrayaan-3 and the sheer difficulty of landing on the lunar South Pole. We unpacked how SpaceX is laying the groundwork for a 2035 space station. We looked at how Buvan and Navik are turning orbital data into on-the-ground economic and military security. And we faced the reality of that 2 to 3% market share.
It is a critical transitional phase. The era of space being a purely scientific, exploratory endeavor is totally over. Access to space and the ability to defend your assets in space is now the fundamental requirement for securing a nation's economic architecture.
Right, to lock this all in, give us the final 30-second rapid-fire revision capsule. 5 facts, 1 question, 5 keywords. Go.
Okay, your 5 must-remember facts. SpaceX for autonomous docking, the 2035 space station target, the 10 billion rupee startup fund, the 2 to 3% global market share, and GSA-7 for defense.
Nice. And the probable question.
Critically evaluate the shift in India's space program from capability demonstration to dual-use strategic autonomy in light of the 2023 space policy.
And the 5 analytical keywords to underline in that answer.
Strategic autonomy, dual-use technology, space democratization, data sovereignty, and orbital sustainability.
Incredible. Which brings us to a final, rather provocative thought to leave you with. We've spent this time discussing how India is pushing to establish its sovereign infrastructure in orbit, racing toward a 2035 space station and preparing for missions to Venus.
Right.
But as the rockets get cheaper and the orbital highways get more crowded, we are running headfirst into a massive legal vacuum. There are currently no binding, enforceable international laws regarding the creation of space debris or the mining of lunar resources or, the deployment of dual-use inspection satellites that could easily function as orbital weapons. As India and other global powers push further into the cosmos to secure their strategic autonomy, how long can this fragile legal vacuum last?
It's a ticking clock.
Will space remain a shared heritage of humanity, as the mid-century treaties hoped? Or are we simply watching the live construction of the next heavily militarized, fiercely contested border? Something for you to mull over. Until next time.